Hello everyone, this is the second video in a series on exponential growth. If you want to see the first video or any of the other videos I'm making about this, you can check out the playlist using the link in the top right or in the description. So in the first video I introduced to you two formulas, one to calculate the factor and one to actually use the factor to calculate a part or a whole. In this video I want to go a bit further on factors. Specifically, I want to explain how you can calculate a part of a part, and I want to explain a bit more about what the factor actually tells us. So starting with a part of a part, and what do I actually mean by that? So let's say you want to buy something and originally it cost 20 euros. However, it's been on discount twice, so it was first discounted by 25% and then by another 35%. Now, unfortunately, that does not mean that you get 60% discount, so we have to calculate this differently. So like before, we can still calculate the factor. And if we have 25% discount, we still have to pay 75%. So using the first formula, we get 75 divided by 100, a factor of 0.75. For my second factor, 35% discount means I still pay 65%. Again, I divide by 100 to get a factor of 0.65. Now, of course, I can take my whole 20 euros and multiply it by 0.75, get the first discounted price, and then multiply by 0.65 to get the second discounted price, the latest price. However, we can also take a slightly different route and instead calculate the combined factor. And how we do that is simply by multiplying our two factors, by calculating 0.75 times 0.65. And that is 0.4875. And this factor is the factor for both of those discounts combined. So all we still have to do to get the discounted price is to start with our original price, the whole 20 euros, and multiply that by our factor, to find out that we have to pay in the end 9.75 euros. Now it still takes the same amount of steps in this case, but especially if you want a part of a part of a part, etc., or if it's the same percentage every time, it becomes easier to calculate the combined factor instead. So that is one thing that we can also do with factors. But the factor tells us a bit more. So far we always had factors between 0 and 1. And we noticed that the part was always smaller than the whole, so we had a decrease. However, it's also possible that the factor is larger than 1. If the factor is larger than 1, then it actually means you're going to get not 100%, not 70%, but maybe 150%, and you get a factor of 1.5. If the factor is larger than 1, if you multiply by something larger than 1, we're actually going to get something bigger, something larger. Then the word part maybe doesn't make full sense anymore. But there are still situations where this is the case. Maybe you get interest on your bank account, then the money increases and it still has to do with percentages, so it still has to do with factors. And of course, we still have a third category. If we had smaller than 1, if we had larger than 1, it's also possible that our factor is exactly 1 and then it is constant. So this is especially useful if the factor has been given instead of the percentage. Then you can immediately see, is it going to be bigger, smaller, or the same? Once we start calculating more of those parts of parts of parts, or if we take the same part of something multiple times, for instance with interest, you will get an extra percentage after each year, so you do it multiple times. You can look at the factor instead and it will tell you a lot, and we will see this in formulas as well later on. And that is where we are slowly getting towards exponential growth, which is what the next video will be about.